one. So you can refer that. That is for the identification of chemical compounds with specific functional group. So some parts we haven't done it, but alkane, alkene, alkyne and alkyl halide you can manage here. Yeah. So if you are given two compounds, you should know how to distinguish them using simple chemical test. They don't ask you to write the reaction, only the observation enough and the reagent. Then this paper, this one, so I remember I left one question for homework. Could you kind of tell me which question I gave for homework? I think all the others I discussed with you. Isomerism questions. The last one, right? Only the last one. Okay. Right. Question number 15. Have you all done this? Did you all get the answer, or shall I explain this in detail? How many of you got this? Please reply to the chat or raise the hand. Those who are able to do it. Last one. Okay. How many of you did? Okay, right. 3 of you are done, no? Good. Okay, right. 4 of you have done. Tamasha, was that hard or did you try this? Okay, I'll directly discuss this. Okay, Tamasha, right. Sure. Right. Okay. Now, this is also from hydrocarbon, right? All the questions we discuss in this paper from hydrocarbons. Then isomerism. Hydrocarbons linked with isomerism. Alkane, alkene, alkyne. And they have incorporated the simple 1 or 2 reaction also with that. And the other most important thing, all these are structured type questions. So they are compulsory questions. All these are structured type questions, compulsory questions. Okay. ABC are structural isomers with molecular formula C5H11Br. Now you can see one hydrogen. So if you replace that bromine also with hydrogen, it will be definitely an alkane. It will be definitely an alkane. Now here, this replace with Br, that means alkyl bromide. Such compounds are called what? Alkyl bromide. All 3 isomers exhibits optical isomerism. That is, that you should better highlight to underline, because it's one keyword given here, one keyword. That is very important information. Therefore, always, even now structured essay, you can't highlight or you can't use tipex and stuff, but anyway, you at least with the pencil you can underline, or else you can in a rough paper, you can roughly mention, write it. Okay, I'll highlight this here. This all three exhibit optical isomerism. Right. So all three exhibits optical isomerism. Then when reacted with alcoholic KOH, ABC gives with alcoholic KOH. I had that different color. With alcoholic KOH, all three compounds gives DEF respectively. D is what? Geometric isomerism. E and F do not exhibit geometric isomerism. Right? Again, you after with alcoholic KOH, then you get the products now. Those products, in other words, out of DEF, E and F. E and F do not exhibit geometric isomerism, so it reacted with HBr. With HBr, both gives the same compound G. Right? With HBr, you get compound G from both E and F. Same compound G from both E and F. E and F. So G is structural isomers of ABC. G do not exhibit the other information. G do not exhibit optical isomerism. Okay, that's what they have given. So you are given boxes here. You have to draw the correct structure. It is not necessary to draw the stereo isometric form. Right. Let's see how to do it now. Okay. Okay. So first you have to take this C5H. C5H11Br, C5H11Br. Right. So how to draw the three structures for this exhibit? So when there are 5 carbons, so I'll put this first this central carbon atom in the middle. And then I had to put 4 different groups. So I can have methyl group, ethyl group, hydrogen, no? Methyl, ethyl, and hydrogen. Right. Methyl group, ethyl group, and hydrogen I can draw. Please raise the hand those who got the first part, at least the 3 structures correctly, ABC. Those who got ABC, the correct 3 structures. Before I write the answer, those who got I don't know any possibility of writing those 3 structures on the screen. I will give the annotation permission for the others on my screen. Enable annotation for the others. Okay. Any volunteers to draw the first 3 structures? Those who have done? Yes. Okay, I'll write it quick. From this slide. Okay. now if you want properly, you can CH3 C2H5 a hydrogen and CH2Br. No, okay, that is one possible structure. Now it's not necessary to expand like this. When you draw the structure, uh, this is like a displayed formula. Yeah, this is not, if you write this not wrong, but I don't think the within the given box you can expand and do it uh, within the given space. So this is correct. This is correct. The answer is correct. But B and now A, B, C, you can write them in any order. Any order you can write, because one can put this under cage C, the one she has done on the screen, and one can put this structure under cage B or even under cage A. But anyway, B and C can be interchanged. So if B and C can, if we interchange, then B and F also should be interchanged. Accordingly, the other answers also will change, right? Then what are the other two structures? You can have hydrogen also as one group around the carbon atom, and bromine also a group, right? Then that way also you can make a optical isomer, right? Okay, let me I'll rewrite from this one, then we can save this space. Answer is correct. I do like this. So the first one, I'll make carbon atom at the center. I'll put here bromine, hydrogen. This side I put CH3. This side I put bromine. This side I put all the remaining carbon atom. How many more carbon atoms out of 5 carbon left? 3 carbon. 3 carbon left. Then I can put CH3, CH3, CH2, CH2. Right. CH3, CH2 and CH2, like this. Remember now, if you want, you can draw like this also. Carbon, here hydrogen, 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 like that. Here Br, like that. But it will consume more space. I don't think you will have enough space to write in that cage all this. But if you write it, no harm. They will give marks. You can put hydrogen, but this is called actually displayed formula. This is called displayed formula. Displayed formula. This is called the structural formula. Structural formula, right? So there are different type of formulas you learn. What are the different types of formulas you learn? One is you learn empirical formula, then you write molecular formula, then you write structural formula, right? Then you can write displayed formula, then you can write skeletal formula. What is called skeletal formula? So example, one of the best example I can give for the structural formula. So you have to be very careful these words in the exam. Write for what they ask, don't write all what you know. So if they ask you to draw the molecular formula, don't draw the empirical formula. If you ask to draw the structural formula, don't draw the displayed formula. If they ask you to draw the skeletal formula, don't draw none of the other. Now either any of the others. So if you take, I'll give one example. If I take here CH3, CH2, CH2, CH3, this is butane. Okay, so this is the structural formula. So displayed formula you have to draw like this. All the connectivity of all the bonds, like this, you have to, that is the displayed formula. So if you are going to draw the skeletal formula for this, okay, I'll write this also. I'll display and write CH3, CH2, CH2, then CH2, CH3, like that, right? Then you get the skeletal formula will be what? You can draw like this, like this. So this is the skeletal formula, right? this corner, each corner you have a carbon. So here one, just to understand that this corner one carbon, here one carbon, here one carbon, here one carbon, like that. That's how you get it. That means this corner you have what? CH3 group. Here is the two corner you have CH3 group, and the other two you have the CH2 group, like that. And that is the skeletal formula. So just draw, you can draw lines like that. If the terminal carbon has OH group, you write here OH, that's it. Then what is this? CH3, CH2, yes, 1, 2, 3, you get here CH2 OH, like that. Is that clear? This one more, the CH3 CH2 CH2 OH, CH3 CH2 CH2 OH, like that. 3 carbon is there, 3 carbon there. So this is how you get it. This is called propanol. Then but anyway, local A level, they don't ask much about these two. At local A level, they don't ask much about skeletal formula. They don't ask. Therefore, you don't need to worry about much. And displayed formula also, they don't ask much. Right? Otherwise, London papers, they ask all this: empirical formula, molecular formula, structural formula, displayed formula, and skeletal formula. All they ask in London papers. But local, mostly they ask the structural formula. But for the structural formula, some students and the teachers draw the displayed formula also. But they don't deduct marks so far. But anyway, remember, displayed formula and the structural formula, two different things. Okay. Therefore, you should know the meaning of these technical term and the word, scientific word used in chemistry. Then let's see now, this is the displayed formula. Okay, right. So then I did the structural formula for that. After that, so what is this? C5 H11 Br, C5 H11 Br. I'll take this one as structure A. So I'll take this one as structure A. Then B. How can I draw one more optical isomer from this? I will shift the bromine into different places. Okay, let me draw like this. I'll put the central carbon atom in the carbon atom at the center. So I can instead of directly attaching the bromine to, they are telling all three are isomers which exhibits optical isomerism. All three exhibits optical isomerism. So I'll draw like this: hydrogen here, and here you have CH3 group. Now I'll reduce. So the only possibility now, I have to reduce this chain. This chain I have to reduce. So if I reduce this to 2 carbon, then it becomes CH3 CH2. Then what to add here? What is left now? So one CH3 group, 1 carbon and bromine. Then that one I'll write as CH2Br. CH2Br, like that. CH2Br. So that is the structure B then. Okay, structure B. So I reduce the carbon chain there. Then next one I can draw third optical isomer. For this third optical isomer I can draw. So I'll put the carbon atom at the center. Then I'll put CH. If you want, you can do like this way also. If you want, you can make it CH2 CH3, yeah, bromine, CH2Br, CH3 CH2. Optical activity, you can have this way. Instead of if you want, you can make carbon, instead of directly connecting, you can shift the bromine into different place. Right? If you want, you can put this bromine here. I mean this bromine, if you want, you can put here also. That way also you can get a structure. Then that carbon become optically active. That carbon become optically active. Okay, I'll draw that also here. Let me draw like this. Carbon, you can put bromine, CH3, hydrogen, CH3, then you can put this side. I'll type bromine here. CH, CH3, CH, CH3, and there are three carbon. There are three carbon, right? So this one you put here. This CH3 you put here. Then also you will get a structure like this. That CH3 you can put here. Did you get it now? 1, 2, 3, 4, 5. Yeah. So this also, which carbon is optically active now? This card, central one. This is optically active. I'll highlight the optically active carbon. This is optically active, or this is asymmetric carbon or chiral carbon. And the other one, next one you can draw instead of, because anyway these three groups you can't change, so this bromine you can put here, CH3, so you can put bromine here. That is how you can draw the other one. I think that's what Pramod did, right? The first structure. So Pramod, this one I'll draw here, carbon, here I'll put hydrogen, CH3, then this one you can put bromine, sorry, not bromine. I'll reduce the carbon chain now. Now I have rearranged this CH3 3 carbon chain, 3 carbon contain aliphatic one. I have rearranged into this. Then I cannot rearrange this anymore. Then I will, what I do, I'll change the bromine, position of bromine. I'll change the position of bromine. I'll put here CH 2Br, and here I'll put CH3 CH2. If you want, you can put Br here, right? No problem. Instead of, you can make this, you can rotate this molecule, can rotate in any direction. You can't just rotate this molecule and you can't tell that is a new structure. Be careful. Some students, what they do, they rotate, like they will draw like this. They will take the carbon here, they put CH2Br, right? And here they put CH3. Then here you get hydrogen, and here you get CH3, CH2, CH3. Then that is this is the other structure. We can draw 4 structures. No, this is the same thing. These two are equal, right? These two are equal. You can't just rotate it and you can't write any direction, so you can't tell that's a new structure. Be careful about that. The best thing is when you write the IUPAC name, if you get the same IUPAC name for two compounds, two structures, that means they are equal. Right? When you write the IUPAC name, you should not get the same IUPAC name. Then only you can understand whether you have done the same structure or not. That is one method you can detect it. But anyway, here they are not asking you to write the IUPAC name. Be careful. Any questions about that? Any question about that, or can you suggest any other structures other than these 3 isomers here? So what did I do now? I changed this CH now, because the others restricted. Now this one I have rearranged. This one I have reduced to this form, and then to this one. And when I make this CH3 CH2, then this becomes CH2Br. That's what I have done. Everything else same. So these two, right? Okay. Any questions? Is that clear? How to get the Tamasha? Tamasha asks, sir, can you explain it again? So these are the 3 optical ABC. Is that clear, everyone? Right. Then next one. Now these three are reacted with whom? With alcoholic KOH. That means what? What happened when you put alcoholic KOH into these three? Elimination of what? HBr. When you put alcoholic KOH these three, what? You get HBr is eliminated. HBr is eliminated. Yeah, very good, Pramodi. Dehydrobromination. What is the single term used for this? Dehydrobromination. Dehydro means the dehydration, dehydrobromination, that elimination of HBr. Dehydrobromination is elimination of HBr. So with alcoholic KOH, dehydrobromination will take place. So I'll write in front of this alcoholic KOH. But anyway, they are not asking you to write this reaction, alcoholic KOH. So here also I'll put A dot KOH, alcoholic KOH, A dot KOH. So what are the three products we get here? I'll quickly draw the structures. When you put bromine, when you put alcoholic KOH to Br, then you get respectively DEF. Remember, when removing HBr, if you want to write this with your red pen, when removing HBr, bromine goes from one. When bromine goes from this, hydrogen goes for the adjoining carbon. Very, very important. Bromine from one carbon, hydrogen will not be removed from the same carbon. Hydrogen will not be removed from the same carbon. Hydrogen goes either from this side or from this side. Right? This hydrogen is not taken out. That one on the same carbon. Is that clear, everyone? Okay, when bromine from one carbon, hydrogen from the nearest carbon, adjoining carbon, not from the second one. I can't take HBr bromine from here and the hydrogen from 2 or 3 carbons away. That is not possible. So here also bromine from this carbon, hydrogen either from this side or from this side. Right? Those are the possibilities. So out of these two, so the highest priority is what? Number one. This one will take place. Why? This side will not happen. Why hydrogen is not taken from CH3 side? Yes, who can tell me? Why when removing hydrogen is removed. Now can a bromine go with the same hydrogen on the same carbon? No. Hydrogen on the same carbon, not possible. Now this bromine has actually two possibilities. Hydrogen on the adjoining carbon. So this one has only one possibility. Hydrogen gone only from this one. Adjoining carbon is this. What is the adjoining carbon to this one? This I'll encircle the bromine. This bromine, what is the adjoining carbon? Adjoining carbon don't take as CH3. This one is not the adjoining carbon. This is 2 carbon. Now this is 1, then this is 2. This is the second carbon. So this one, there are 2 adjoining carbon. This side and this side. So the third structure, only one adjoining carbon can take away the hydrogen. Because this side this side no carbon. Only from one side the adjoining carbon. This bromine has both sides carbon atom. This the structure A also, bromine can remove hydrogen from either side. But the highest priority is from when removing hydrogen is removed from the carbon containing least number of hydrogen atom. Write down these two information. Actually not the answer, I don't know, because you can look at the marking scheme to get the answer. Look at all 6 boxes, you can finish within 1 minute. But this is what if you those who have not or else if you should better write this with your red pen in your short notebook. When during dehydrobromination, bromine from one carbon and hydrogen is removed from the adjoining carbon to the bromine carbon, right? In dehydrobromination, what is dehydrobromination? Dehydrobromination means elimination of HBr. It's an elimination reaction. Dehydrobromination. In dehydrobromination, Br from one carbon and this is the most important thing, and hydrogen from nearest carbon or the adjoining carbon, hydrogen from adjoining carbon, containing least number of hydrogen atoms. This is very, very important. This is valid for all any other reaction also, similar reaction like this. I'll highlight that part. Hydrogen from adjoining carbon containing least number of hydrogen. There are two conditions here. Adjoining carbon, one condition, and second condition, least number of hydrogen atoms. Is that clear? So what is the reagent used for the dehydrogenation? Alcoholic KOH. Is that clear? Now I can easily decide, no? So therefore this one, the hydrogen is gone from this carbon, right? This carbon. Let's see now. Shall I erase this? Did you all finish copying down in a short note? Please try to maintain a separate CR book for organic short notes and the summary note I gave, no? Summary note like summary of benzene reaction, summary of alkene reactions, like that. In that one you can write it, right? Under alkyl bromide you can write this, under alkyl bromide or alkyl halides. Alkyl halides can be alkyl bromide, alkyl chloride, like that. Alkyl chloride, or it can be alkyl bromide, or alkyl chloride. Is that clear? Right. So those words also you have to be familiar. Now anyway, some papers they don't give the word removal of HBr, right? Instead of that they will give dehydrogenation. Sometimes instead of adding Br2 they will give bromination, or instead of removing elimination of water molecule they will give dehydration. So dehydrogenation means what? Removal of HBr, right? So these terms also you should better remember, otherwise if you don't understand that word then you will find it difficult to do the rest of the question because of one word, right? So is that clear? Because when you get a similar reaction like this, then you know how to remove HBr, right? How to remove HBr, what is the reagent, right? All this important. Okay, I'll erase this now, right? You are done, right? Anyone still copying down? Please raise the hand. I'll erase this this special note I gave. That we have to remember. Then next one, I'll write the products. I'll quickly write the products now form. First one, what is the product form? From A you get a double bond. Now you know now you can easily decide the position of the double bond, no? You can easily decide the position of the double bond. So I'll write here okay. So here CH and then CH3. This side you get a double bond, this side you get a double bond, right? This if you know, this is the same that earlier it was optically active, that carbon is here, right? So that hydrogen and CH3 no change. Then this side you get what happened, this CH2 become CH and then the rest is there, CH2 CH3. Now this one shows what? Optical isomerism. This one shows optical isomerism. How come? This is the structure D, right? This is the structure D. This will show optical isomerism, right? Oh, sorry, not optical, but geometric. How come this? You can draw cis trans like this. Here you can put HH and here you can put CH3 and here CH2 CH3. That is how it become. If you want, you can mark that with the pencil. This is how it become a geometric isomer. So this is the cis form. This is the cis form, cis isomer. Then if you interchange these two, and then you will get trans one. One side you can interchange. I mean, left side carbon or right side carbon. Is that clear? Right. So that means what? The structure D shows geometric isomerism. So that was, I'll put a tick here. Now that is satisfied. All three. Now that's satisfied. Then also you can, with alcoholic KOH, we got the products. Exhibits geometric isomerism. D exhibit geometric isomerism. That also we got. No, this is geometric. No, geometric means is trans. This is geometric. If you have a simple doubt, tell me. Not to do 100 questions. At least if you do 5 or 6 years, now I have done here itself, I have done 5 questions, then definitely you will be getting, because the risk of this, I am taking time and doing this, because in the A-level paper, mostly this isomerism part, rather than put in a MCQ, some papers there was MCQs also, they can relate this to the structure cell questions like this, then it will be more difficult, right? Then they can ask optical, geometric, everything, cis trans, and then is structural isomer. So the isomerism part, the entire that flow diagram, they can test from one question in the structure essay. So because it's compulsory, either you like or not, it's compulsory, you have to do it, that's why. So then I will erase this because, and they have given here, it is not necessary to draw, it is not necessary to draw the stereoisomeric. Can you hear at the last one within bracket? That means this one is not necessary. Why? The stereoisomeric form, otherwise you can take D also into two forms, no? D, the cis form and the trans form. That means you are not expected to draw it. Right. Removal of, okay, from this asking, sir, can you explain again? Can you explain again removal of hydrogen atom in dehydrobromination? Okay. When removing hydrogen, it is removed from the carbon containing least number of hydrogen atoms. Okay, number one, removal of HBr. These are the two conditions. Removal of HBr, there are two conditions. One is what? From this asking that again, that's why I am explaining this again. Removal of HBr, one condition is what? Hydrogen from bromine. Anyway, you have to remove it. Now, bromine, anyway, you have to remove. Hydrogen from adjoining carbon or the nearest carbon. Now, the other most important thing, to remove hydrogen from the adjoining carbon, there must be hydrogen on it. Do you understand what I'm saying? There must be hydrogen on it, right? Otherwise, without, if there are no hydrogen on it, then you can't remove it. Then they are, okay, I'll give one example. Sometimes the students, so be careful, this kind of formula. If you get, I'll give one example like this. Here I have bromine. This side I have carbon. This carbon has CH3, 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 right? This side I have hydrogen. This carbon, this side also have CH3, CH3, CH3. Now, can I eliminate HBr from this compound? Right? Raise the hand those who say yes, we can remove HBr from this compound. Can I remove HBr from this compound? Can, no, can't? Huh? Can or can't? Yeah, we can't remove. Why? Because no, these are the two adjoining carbon. Bromine on the middle carbon. Bromine. Remember, hydrogen is not removed from the same carbon. Right? This the bromine attached to this carbon. That carbon has one hydrogen. Hydrogen is not removed from the same carbon atom. Hydrogen from adjoining carbon. That's why I'm telling adjoining, not from the, and adjoining means not 2 or 3 carbon away. So you can't take hydrogen from the second nearest one. So we call it alpha carbon, beta carbon, like that. But I am not going to. This will be more complex. I'm using the simplest term, nearest carbon or the adjoining carbon. Not nearest also not valid. Nearest can be the any nearest carbon. because if the next carbon has no hydrogen, then you can tell the next nearest carbon is that. No, not the nearest, adjoining carbon, adjacent carbon, right? If there are no hydrogen on the adjoining carbon, that also you can write. If there are no hydrogen on the adjoining carbon atom, or the nearest the adjoining carbon atom or adjacent carbon, then HBr cannot be removed. So therefore, if you put alcoholic KOH here, nothing will happen. If you put alcoholic KOH, nothing will happen. No reaction, no reaction. So those things, be careful. MCQ paper they can ask me, right? Or else I can make this side. Actually, when I am discussing, I am trying my best to explain the maximum theory. Theory means like kind of important theory. The most important part of the theory when answering this question, that one I am trying to put into your head. Right? This is one a very important point. Then the second one, since probably asked to explain that again, hydrogen from the adjoining carbon. If there's more than one option, more than hydrogen adjoining carbon, there are two carbon now. Then what is the second selection criteria? Hydrogen from the adjoining carbon, bromine is removed from the carbon containing least number of hydrogen. Least number of hydrogen on the adjoining carbon. Least number of hydrogen on adjoining carbon. When there's more than one possibility, right? When there's more than one possibility, like the Lewis structures for a given structure, if there's more than one possibility of drawing structures, we call them Lewis structures. So here, when there's more than one possibility of removing hydrogen from if there are two adjoining carbon containing hydrogen from either side, from each side, then you have to go for the least number of hydrogen. That's why you can look at from the structure A, I took hydrogen off from left side, not from the right side CH3 group. I cannot remove hydrogen from the right side CH3 group. Why? Because that contains 3 hydrogen. So this side contains only 2 hydrogen. When removing hydrogen, hydrogen is removed from the carbon containing least number of hydrogen. This is something called Markovnikov rule. And when adding, if you want to write that also, if you are adding HBr to this again, that's what they are doing next. See, actually this is what they are testing here, not anything else. So hidden secret of this question is this part what I am explaining now. When adding HBr, if you want to write that also to your short notebook, when adding HBr, hydrogen is added, opposite, the same thing opposite. Hydrogen is added to the carbon containing more hydrogen. Again I am repeating, when removing HBr, hydrogen is removed from the carbon occupied with least number of hydrogen atoms. Least number of hydrogen. If there are no hydrogen, then cannot remove. CH is better than CH2. CH2 is better than CH3. That's what I am telling. When adding HBr, hydrogen is added to the carbon containing large number of hydrogen atom, or the highest number of hydrogen atom. Right? Most occupied carbon atom with hydrogen. Is that clear? Any questions from this? Is that clear? Your doubt now?
Yes, sir.
So even if you have a simple doubt, you should clarify that here itself, because I'm not going to do 100 questions from this. So here I have about 5 questions. Then you can manage the rest from the theory you learned here. Otherwise you will have to memorize. Without this explanation, if I can do more questions, but you will have to memorize the answers of all those questions. That is also one method. Some students, they reach, okay, this is your target A with maximum marks, with highest marks. So now some students, they reach this target in different routes. So you can reach to this target through a different route. From Colombo to Galle, you can go through the highway, or you can go through different routes. So then that means hard working, they will be really kind of exhausted after A-level exam, right? So that they will tell the hardest exam I face A-level. Some students, they reach the target without making much effort, right? You can do 100 questions and go to 100 questions you can practice to go to A pass with maximum marks. The other students, they do only 5 questions and go to the same target. Why? This one is doing 100 questions and get the experience only of answering questions, and he will memorize. If this way is given, I have to do this way. This way is given, I have to do this way. That kind of, if you are going for that pattern, you need more questions. But with understanding, if you do 5 questions, then without making much effort, you can go to the Same target. But some students, even though they do 5 questions, they need to practice more and more example also because they don't remember that. So it depends on your strength and capabilities. But so therefore the best thing is try this one first, and then if not enough, then you can do more questions of that type. But the same explanation, if you do 100 questions here, the same explanation, same scenario, same theory, right? Okay. There are students also who have I mean the childrens of those who are working at NIE, National Institute of Education, Ministry of Education, and Department of Examination. There are I mean the staff members of these three places, Department of Examination, and the teachers. I'll give the category. I have so many examples. Some of them they are not going for tuition also, only from the school. Number one, those who are working, the staff members of the Department of Examination. Number two, Ministry of Education. Right. Then National Institute of Education. And then after that, next category is school principals. Government schools. I'm talking about government. Then school principals. Then teachers. And actually university lecturers, they don't know about much about that. Department of Examination, Ministry of Education, National and Zonal Education Office. The members of like mostly the maybe we call it directors, assistant directors, ADE, additional director of education, like the Zonal Education Office, Kalapadhyapana Karyala, Zonal Piliyandala, so like that. Zonal Education Office, the staff. So their children, they get O-level good results, A-level also good results without making much effort. Why? They get everything, the prototype papers, marking scheme, everything, and they know what is the path. They know the path that the student should send. So the the majority, nearly more than 90% of the parents, they don't know that. They don't know. So they know what is the top mark in examiner and who is going for paper marking. These people, they know which one has the most experience of paper marking A level and which one is performing well. So they know that from the staff itself, and they know what type of questions they have to follow, what type of paper, so updates, any changes in the syllabus. So some of them, they know the lecturers, university lecturers, those who are adding questions to this. I'm not telling they are getting the questions. None of them, they will not get any clue about the questions, right? So that is like the most reliable department in Sri Lanka is what? You can't bribe and get A pass. You, even if you give $1 billion money, can you request at least increase by 1 mark your paper? No, you can't do it. Even president cannot access the Department of Examination. President even. So who has authority? Commissioner, Vibhag Commissaris General, right? Director General of Department of Examination, Director General, right? Or Commissioner. Actually, we call it Commissioner. Commissaris, Commissioner of the Department of Examination. So if they actually that is the most reliable. That's why our A-level results highly recognized all over the world. If you get here 3 C's, biology, chemistry, physics, sometimes you can do medicine in Bangladesh, India, and some other countries. Therefore, for 3 kids, right? Even 2 B's. But here, even 3 years, sometimes Colombo, the students, some students, they find it difficult. With 3 years, they will find it to enter Colombo medical faculty. But the other countries, for 1B, 2 C's, they offer medicine. For Sri Lankan A-level students, local A-level. So therefore, our A-level results and all results highly recognized. Right? That's why even the international schools, also the private schools, they do this national exam. Otherwise, they can have their own exam and give a results sheet and ask the international community to accept that. But that won't happen. That's why I'm telling. This is if you go to police, Sri Lankan police, or custom, harbour, or department of the motor traffic department, you can bribe and get done the things. No, right? I'm not telling everyone is doing it, but you can get done those things. Right? But this one you can't. You can change your birth certificate or marriage certificate, but you can bribe and do it. But you can't bribe and change your from the department. From the other places you can have fake certificates, but from the Department of Examination you cannot change your results for any reason. I don't. This is one of the best example. There was a commissioner called Anura Tennakon, as I remember, this previous commissioner of Department of Examination. You might not believe his son, commissioner of the Department of Examination, his son faced Royal College, faced 3 times A level, but he couldn't enter even university, right? That is one of the best example I can give, right? So how reliable that place? Otherwise, definitely you can know commissioner, the son of the commissioner of the Department of Examination. His son he tried 3 times, but he couldn't enter university. That is one of the best example I can give, right? Then next one, okay. That's why it's highly reliable. Like no one is complaining, right, about the oral results or L results in Sri Lanka from the Department of Examination. They don't allow. They have changed it and they have reduced my one, and this one has got 9s by. So have you ever got a complaint? Leaking of the paper and something that has given this paper, this has given this paper. That's why. That's why majority of the more than 90% of the parents, more than 90% of the parents, they ask after all the results after 9s, or my son or daughter got 9s, to which teacher. So they go for the most popular teacher. That tuition class, this tuition class, that tuition class, this individual class. They are sending their children to so many tuition classes to fill the maximum, right? To give the maximum, right? But they don't know how to. So then they will like ask from the other parents, right? They ask from the other parents, and this one is going to this class, like that. That's how they select the classes. So then what happened? That side is doing from Redox 100 questions, from that one 200 questions, right? That is how they do it. That's why I told there are two paths. Some students reach the target directly, like shortest path. Some go this way, some go for this way for they pass, like that. That is the difference, right? Even other exam also same scenario. Okay, one of the best example you can see, most of the top people, most of their parents are teachers, right? Benefit if the parents are teachers, and okay, right, the parents also, but anyway, that is happening in our country, right? Then next one, from structure B, let's see. Okay, now this is geometry, so that you, okay, I'll write here geometry. This one from B, when you put alcoholic chaos, I have marked with that brick red color, the yellow color, how bromine and hydrogen is removed. So I can get easily the double bond now, right? From structure B also I can easily get the double bond. So then you guys get what? CH3 C. Then I can write hydrogen, then I have put the double bond. No, I have put the double bond. This side you have the CH, that CH3 no change. That CH3 no change. Then you get CH3 double bond. Will this shows is trans? No. Why? This one shows is trans. The reason? Because there are two similar groups on this carbon. There are two similar groups on this carbon. Here I can't draw cis trans because it's both. There are two similar groups here. Then you get here carbon, and then you get here hydrogen. I put CH, then CH3, right? That is the next structure. Is it clear? Then from that is E, no? That is E. When you put alcoholic case to the structure C, I have put bromine. Now I know from which carbon the hydrogen is removed. No? I have already marked that with the bromine, and the arrow I have put for that carbon. That carbon has only one hydrogen. That hydrogen will be removed. No, that hydrogen will be removed. Then I'll get here CH3, CH2, C. Then you get here double bond. Here you get double bond, and here CH2, and this side CH3 no change. That is the structure D. If you predict this, you have already got what? Out of the 7 cages, 6 cages you have got it, no? Sorry, D, E, F. Sorry, this is F. D, E, F. Is that clear now, everyone? Any questions on this? So this is the double bond. Here the double bond. Here the double bond. Done? Any questions? Okay. after that, how to get the structure G? How to get the structure G? So how to get G here? They have given when reacted with HBr, E and F give the same compound G. E and F give the same compound G. When reacted again, that means what? After removing HBr, you add HBr. So this one is reacted with HBr. But E and F, this also reacted with HBr. Then you get the same compound. Same compound. So that is G. Okay, how to add HBr? Again, I am writing now. When adding HBr to alkene or alkyne, please write that if you want. When adding HBr, hydrogen is added to the carbon containing more hydrogen, to the carbon with more hydrogen, most occupied carbon with more hydrogen. So now there are two possibilities. Now I'll mark here. When adding HBr can be, hydrogen can be added to, so I put here hydrogen, hydrogen. Hydrogen is added, can be added to this carbon or this carbon. So which carbon has more hydrogen now? Which carbon has more hydrogen? When adding HBr, hydrogen can be added to either this carbon or this carbon around the double bond. Which carbon has more hydrogen? That carbon will get, which carbon has more hydrogen? Then you can easily decide to which carbon the hydrogen is added. To the other carbon, bromine. To the other carbon, bromine. Is that clear? Please write it with the red pen. When adding HBr, hydrogen is added to the carbon containing more hydrogen. Hydrogen is added to the carbon containing more hydrogen. Okay. Shall we draw this structure now? How to draw this structure here? How to draw this structure? I'll put here carbon. This side you have what? CH3 group. CH3. This side you have CH3. CH3. And this side you have CH2 CH3. CH2 CH3. And here you get Br. Like that. That means around that carbon there are two CH3 group, there's one methyl group. You can rotate this any direction you want. You can rotate this clockwise or anti-clockwise. By rotating this clockwise or anti-clockwise, you can't tell that's a different structure. That is the structure G. Is that clear? This is the answer. Any questions? Please raise the hand without looking at the marking scheme or without looking at the answers. Those who got all 7 structures perfectly correct, please raise the hand. Without looking at any marking scheme, those who had done with this understanding, how to add HBr, how to remove HBr, how to draw the geometric isomer, how to draw the optical isomer, with this understanding, all 7 structures are perfectly correct. Right. No one. Pramod raised the hand earlier, right? Before. A, B, C, D, E, F, G. At least 6 structures correct. Pramod 6 correct, right? 5, 4, 3 structures correct at least out of these 7. In Haragat. Right. Okay. Anyway, any questions about this? Any questions? Right. Okay, so then let's move on to the next part. So that's all. Now this paper is completely done now, right? Shall I erase the screen? Anyone still copying down any of this? I'll give 1 minute again, double check if you have anything to copy down. Right, okay, so shall I erase this? Right. Then next part. Okay, so we are talking about benzene reactions. Okay, this paper completely done, right? Okay. We discuss about the reactions of benzene. Reactions of benzene. To discuss this further, so this paper also we have done. Wait. Okay, this 2015 paper. There are some more questions here. This is actually 2015 paper. There are some questions. Let's see. I have 2015 paper. I have not in this one, right? If you want, you can mark 2015 paper 4B also. You can do most of the parts. 4B. They have given the reagents and the reactions anyway. I'll share the Zoom whiteboard now. Right. Can you please check the last part? I explained the summary of the reactions of benzene. I mean, orthopara directors, meta directors, monosubstituted benzene, and resonance structures and all we discussed. No, please check and tell me. Did I give the summary of the reaction of benzene? I gave, right? See, we have the summary of the reactions of benzene. Number one. And orthopara directors, meta directors also I told, right? Then monosubstituted benzene also did I give the reaction? So say example this methyl benzene again react with someone, that also did I give? This is called monosubstituted benzene. Did I give that one? Done? Can you please check with your stuff? These two we have done, right? Okay, deactivators done, right? Okay, Pramati. Now we have to discuss under reactions of benzene. I'll give a very simple conversion like this. Let me imagine. Okay, with your that understanding, I want you to do like simple conversions related with the aromatic compound like this. I'll take. I want you to do this conversion. I want you to convert from this to this. This one, how to do it? Because more marks allocated in the LL paper for this conversion part. I'll go a small hint. You need with 2 steps you can do it. With 2 steps you can do it. Any volunteers? How should I start? I had to attach CH3 group and N2 group. Please look at the reaction summary of benzene and tell me which group should I attach first. So nitrobenzene and methylbenzene, what are the reagents? Yes? Any volunteers? Just tell me. How can I do it? Yes? What? Tell me the reagents. To make methylbenzene, what are the 2 reagents we use? Anhydrous, AlCl3 and CH3Cl, haven't you done? To make methylbenzene, anhydrous AlCl3 and CH3Cl. You have done it, right? And the other one nitrobenzene. Okay, I got the chat, I think. Yeah, answer C. Conc H2SO4 and conc. Yeah, that is to add NO2 group. Yeah, to add methyl group, CH3 group. You have done it, right? You have check with your any. So I will draw like this. So there are 2 steps here to do this conversion. First I can do one structure and then I go for the other one. So what should be here? If you get a in the exam like this, how to fill this gap? Can you quickly copy down this? Aromatic conversions. So what is the reagent here? What is this? So if you get this like this, so here these are the 3. Okay, can you tell me what is the first one? First step and the I have put here the first step and the second step. Tell me the reagents, and the middle the intermediate compound form. So this is our final target. The starting material given, final product is given. So in between, so what is the intermediate form and what are the 2 steps involved here? And reagents, on each arrowhead you have to write the reagent. Now can you annotate on the screen, my screen, and write the reagent and the product? Anyone, hurry up. Look at your notes, otherwise no point of giving the reaction summary if you are not referring to that. Who can give me? Yes. Tamasha, Vinhara. What is the first step? The reagents. Okay, please raise the hand. Okay, to add CH3 group. Okay, first step we had okay, Tamasha gave first step we had to add conc HNO3 and H2SO4, no? Okay, then Tamasha, if I add conc HNO3 and H2SO4, then you get here nitrobenzene, NO2, NO2. You can add, okay, this also you have to be very careful. You can add this NO2 to anywhere you want, because all the carbon atoms say if you only can add here, no problem, right? No problem. Conc HNO3 and conc H2SO4. I'll add that here, NO2. Good. Okay, first one you have to add conc HNO3 and conc H2SO4. Okay, you can complete the answer now. Any other alternative method? Any other other than this? Can't I add H2SO methyl group first? Then you get nitrobenzene. After that, what? This is what director? Yeah, Pramati, correct. Anhydrous AlCl3 and CH3Cl, anhydrous AlCl3 and CH3Cl. Correct. So that, because this is a meta director, so NO2 come here, then methyl come to this one. Some of you might ask, can't we put the NO2 now? Is this changed? Because then you get like this now. Remember, both these are same. Okay, both these are same. I'll write here. If I put here NO2 and meta position, if I put CH3, both these no change. Both these no change. Both these having the same, because it's when you start numbering, you give here number 1 and here number 2 and here number 3, right? No problem. Here you can put 1 2 3. So the third carbon methyl group is the priority name because activated. So metal NO2 come to the third carbon, that is the meta position. In both these NO2 on the meta position, therefore both these are same. It's not a problem, right? But this, if what happen if you do this way, if we still add CH3 group first, then the problem will arise. Problem will arise if someone adds CH3 first. Why? If you add CH3 first, problem is when you are going to add NO2 next, then the problem, first you put CH3 and then you put NO2, then CH3 will come here, NO2 come here, then you get what? Para position NO2. This is wrong. Therefore first step, you should never add in this conversion methyl group. Why? Methyl group ortho para direct activate of benzene, so then NO2 go to the para position. Is that clear? So same reagent, but you have to put them in the correct order. Understood? I'll give one more similar one. Okay. Please copy down this. Shall I erase this? Right. Then next one. Okay, don't erase. Right, okay, probably you can copy down. When you're done, please tell me you're done. Okay. Please raise the hand, those who are still copying down this. Right. Okay, when you're done, please lower your hand. Right, organic conversions, simple organic conversions with aromatic compounds. Or reactions of organic conversions related with the monosubstituted benzene. Right, done, no? Okay. Then I'll erase this. Then I'll give the next one to do alone. Number 2. Let's see like this. Number 2. This one. CH2 CH3, right? CH2 CH3. This one can you do alone, or can you annotate on my screen? So this is, I have got the starting material and the final one, and you have to show the path of how to synthesize this. So this also I'll give a hint. Sometimes in the structures they will give the number of steps. Sometimes they will give complete this conversion in less than in 2 steps, or sorry, less than in 4 steps, like that. How to do this? Can you if you only write on my screen, or else you can quickly tell me the reagents and the reactants. Yes. Okay, Tamasha gave first CH3 CH2 Cl, and then conch NO3 conch H2SO4. Any other options, alternatives here? Right? So I didn't get any. Okay, good. Pramodi also gave. Pramodi gave first conch NO3 and then this one. Now, what should be added first? Either we should add ethyl group first or nitro group. We should add either ethyl group first or nitro group. Ethyl group first. Why? Ethyl is the orthopara director. When you add nitro group first, what problem will arise? Then the steps wrong. You can use the reagent, but if you don't do that in the correct sequence, then you will end up with a different product. So what should be added first? Ethyl group. If you add nitro group, this problem will arise. So I'll draw here. If you first add NO2 group, what happened? Ethyl group goes to the meta position definitely. This one will go to the ethyl group goes to the meta position. Then is a different structure. So that path is wrong. Is that clear now? So this is what I want you to learn. This is also the test in the exam. So that is wrong. Therefore, what is the answer now? First you have to add ethyl group. What are the reagents? Anhydrous, AlCl3, then CH3, CH2Cl. Then you get ethyl group. You can add either side, no problem. You can add ethyl group to any carbon you want. There's no rule you have to add to any carbon. All the carbons are identical. If you check the just benzene, all the carbon atoms same. Now after that you have to add NO2. After that you have to add NO2. How to add NO2? Conch NO3 and conch H2SO4. Conc HNO3 and Conc H2SO4. Is that clear? Now NO2 come to the what? Para positions. If you take this one is number 1, then you can take 1, 2, 3, 4. Fourth is para position. Is that clear? That number, do you want me to explain again? First attached group number 1. So if you take this one CH3, then you get what? 1, 2, 3, 4. Then this is the para position. Then the next group go to the para position. It's called para number 4. If you add here CH3 group, imagine I can add the CH3 ethyl group to any carbon I want. Imagine if I add ethyl group here, what happened? I can add to any carbon. Then what is the fourth carbon? So this is CH2 CH3. Okay, this is ethyl group. I add to this carbon. Then I can write 1, 2, 3, 4. This is the fourth carbon. Then the fourth position you get the ethyl group like that. Nitro group. Nitro come to here. So auto para director. Is that clear? So therefore you then is both the same. You can rotate the molecule in any direction you want. And yeah. Any questions? Any questions? Then so I discussed the first two. So the next one I wanted to do alone. Okay, shall I erase this? I'll go to the next one. Number 3. Done, everyone? Anyone still copying down? Please raise the hand. This one done, right? Okay. Then next one, third one. Third one I'll put like this. How to do this conversion? How to do this? Write with the black. Same thing, I didn't change it. I changed the color, that's why. COCH3, COCH3. Okay, how to do this? How to do this? Any volunteers? What is the first step? Look at your reaction summary benzene and the monosubstitute benzene. How to add ketone group? CaCH3, how to add? I think we call it Friedel-Crafts acylation, alkylation of benzene. Okay, Tama, what should be added first? Yeah, very good. Because ethyl group is orthopara director, that the ketone group is meta director. Very good. Okay, so you have to add ethyl group first. You have to add here CH2, CH3 first, and then you have to add ketone group. So here I have put AlCl3 anhydrous. Okay, anhydrous AlCl3, CH3, CH2Cl. And then I should add CH3 COCl, again anhydrous AlCl3 CH3 COCl. Is that clear? Understood? CH3 COCl. Any questions? What is this mechanism called? Both these reactions what? Electrophilic substitution reaction. What are these? Electrophilic substitution reaction. If you want to write that also. First reaction also electrophilic substitution. Number 2 also electrophilic substitution. So if you want to write here first one, active species will be CH3, electrophile will be CH3 plus. Second reaction, electrophile will be CH3CO plus, like that, CH3CO plus. Okay, first one CH3 plus, second one CH3CO plus. Understood? Right, shall I erase this? Please write it. Reaction 1, this is the electrophile. And reaction 2, this is the electrophile. And please write everyone, both the reactions are what? Electrophilic substitution reaction. Both the reactions are electrophilic substitution reactions. Electrophilic substitution reaction. Done. And next one. Next one, I erase this. Let's move to the next one. I want to do it alone. That is number 4, no? Number 4. Fourth one. Benzene CH2 CH3, yeah, COCH3. Can you do this alone? If you want, you can annotate on my screen. Yes? Can you quickly reply? How to do this conversion? Okay. If you want, you can annotate on my screen. Others, what should be added first? Yes, correct. Tamasha gave CH3COCl first and then CH3 CH2Cl. Very good. Yeah. First you had to add what because you have to add, if you add ethyl group first, that will be a problem. First you have to add CH3COCl because that is a meta director. That is a meta director. So you have to get CH3. If I can add here, no problem. I can add down that any carbon. So what are the reagents? Anhydrous AlCl3, anhydrous AlCl3, anhydrous AlCl3, and then CH3COCl. Then you have to add anhydrous AlCl3, CH3, CH2Cl. Then only this becomes the meta carbon. No, first this is 1, this is 2, this is 3. That is the third carbon is the meta carbon. So that is a meta director. That is a meta director. Meta director. Right. If you get ethyl first, then it becomes orthopara director. Ethyl group. Right. Then shall I erase this? Anyone still copying down this? Right. Then next part, number 5, no? Number 5. Can you quickly do this? Because I can't do the questions without proper understanding about this. The next part of the questions under organic chemistry. If you take number 5, I'll give the this one like this, methyl benzene. This is bit more complex than the previous 4. I'll have here C double OH group, and meta position I'll put here C double OH, and here you will get NO2 group. How to do this? NO2. Actually, I'll go a small hint. This one you can't do in 2 steps. You have to go through at least 3 steps. Minimum 3 steps. You can't directly get because anyway there's no way of directly attaching the COOH group. You can't produce benzoic acid directly from benzene. That's why. How to do this? That is little tricky. Like if you can do this alone, that means you have got this perfectly. Okay, I will give the list of the reagents here. Then you will. I'll give a small clue. I'll give some papers, A-level papers, structured essay. They give the list of the reagents required for this conversion. I'll give like this. You need anhydrous AlCl3. Then you need CH3 Cl. That is one, and then you need acidified KMnO4. Acidified KMnO4. Check your monosubstituted benzene whether I have given this reaction. Acidified KMnO4. Then you need conc-H2SO4 and conc-HNO3. These are the reagents and the reactants required. Now you should be able to do it. Yeah, acidified K2Cr2O7 also can, but acidified KMnO4 is more powerful than that. Okay, Tamasha gave one answer. Conc-HNO3, conc-H2SO4, 1. Then CH3Cl second with anhydrous AlCl3, Tamasha. You can't just add CH3Cl. And then third will be the oxidizing agent. Good. Very good. Very good. Good. Others? Any other volunteers? So this one you can't, if it is in the structure essay, you can't do the trial and error. You can't write the answer and again you can't erase or cut or typex. You can't do it, no? So best thing is you have to use a rough web and do it separately, and then you can do. Okay, now so how to do it? Any volunteers? Tamasha gave the correct answer. What about the others? What should be added first? So you have to plan it. This is where this is from this I will start, and from this I will start. This is my first step. This is my second step. This is my third step. If you mentally, if you predict that, then you can do it. You can't do half. I do this one. Can't continue. So I got stuck. This is something when you are going from Colombo to any other, like maybe a trip or somewhere. You should know your destination, and you should know your route. So from here I'll go to this way. After that I'll go to this place. After that I go to my destination. So you should know the path. You can't without predicting the road. You go to half and ask from the people where should I go now. So then you will get stuck in the middle. No, this is also like that. Not only the first one. You should know exactly this is how I should reach my target. You have to plan it. Otherwise you can't do trial and error. How I will start somewhat. You without looking at the last few steps. You start with whatever the steps you want, and then you can't. You will be in trouble in the middle. So what should be added first? because they are in the meta positions relative to each other, no? Then you have to put the meta director first. Can you understand that? You have to add the meta director first. Can we add directly COOH group? Can't. If we can directly add COOH group, you can get NO2 to the meta position. But since we can't directly add COOH group, we will put NO2 first. NO2 first. So then you get nitro group NO2. What is added? Concat NO3, concat SO4. Now when you do lot of conversions like this, you automatically remember the reagents. What is the benefit of doing lot of organic conversions like this? One benefit, you are trained to do it, but the second one, you automatically remember the reaction. Otherwise you have to memorize that flow diagram of the summary note again and again to remember the reactions. Without the reactions you can't do the conversion. So after that you can attach methyl group here. If you have any other alternatives, you can tell me. Here you get NO2 and then you get methyl. After later you will put the reagents. Then you oxidize this. You can oxidize this. What is the second step? Second one, you know the reactants, right? The same thing. What AlCl3 anhydrous, AlCl3 and CH3Cl. How to convert CH3 group to COOH group? What is added? Oxidizing agent, no? Oxidizing agent, that is acidified KMnO4. Acidified KMnO4 will oxidize CH3 group to COOH group. CH3 group to COOH group. Please raise the hand, those who got this with this understanding perfectly. How many of you got this? There are 3 steps here. Okay, Tamasha got this. No, very good. Right. Can you please quickly copy down those? Please raise the hand. Those are still copying down this. All are done. Shall I erase this? Done, no? Okay, I'll do a similar one again. Okay, others should try to do this. Number 6. Shall I erase this? Right. Next one, number 6. I'll do this conversion. Benzene okay, can you do this? Can you do this? Oh, wait. Sorry, this is Cl and let's say wait 1 second. This one COCH3. Can you try this one? Any volunteers? Both are meta directors. Both are meta directors. You can do this. If you want, you can annotate on my screen. I have given the annotation enable for the others. If you want, you can draw the structures and do it. No need to write the reagents, at least the structures, arrow and the product, arrow and the product, arrow and the product, like that. Any volunteers? Okay, Pramati gave Tamasha gave COCH3Cl, COCH3COCl first, okay, and then CH3Cl and then acidified KMnO4. Very good, excellent. Tamasha, very good. You have got it. What should be okay? First you have to add CH3. Okay, Pramati, correct. What is the next one? After adding COCH3 or the ketone group, but then can you add what should be added next? Pramadi. No, okay, CH3 acidified came, first CH3 group and then COOH convert into COOH group, and then yeah, that way also you can do it, no? There are two alternative routes for this. There are two possible answers for this. Ishara and Vinhara no reply, no. Okay, please refer your reactions also. I have given a summary, right? What should be added first? What should be added first? Having that in your mind, you can add meta director first. Then you can add the second group to the meta position. Is that clear? Is that clear? So first you can add COCH3 first. How to add COCH3? Anhydrous AlCl3 and CH3 COCl. Then you can add to the meta position CH3, having that in your mind, but oxidize enough that to get COOH. You can get the COOH, or else you can get COOH you can get from CH3. How? By oxidizing agent, by adding acidified KMnO4. So I'll write here COCH3 is a meta director. Now remember, those who find this little difficult, please refer the orthopara directors and meta directors, the note, or activators and deactivators, refer the note, and reaction summary of benzene and monosubstituted benzene. That's what you need. There are, what are the two things you have to refer, especially those who are not replying. I don't know whether you find it difficult. Okay, Vinhara gave right. Since Vinhara and Ishara is not replying at all. So COCH3, then you can put here methyl group, and then you can oxidize this by putting acidified KMnO4. Is that clear? Now I started with one step reaction, then two steps. Now I have moved to 3 steps. Some of the organic conversions in the LL paper, there can be 6-7 steps. Okay, highest marks allocated for this one in the LL paper. Remember, essay type, organic chemistry essay type, you get more marks out of all the MC essays, organic chemistry questions. The highest marks offered for this part, because you have to do it alone. Organic synthesis. Organic synthesis, this is example, maybe it can be a pharmaceutical product or medicine or drug. So you know your drug, you find the specific maybe the protein and the enzyme, and you put a blocker, right? So enzymatic reaction, that's what the medicines are doing. So you prevent that reaction, right? Unwanted reaction you prevent, or else the target, the specific maybe protein has binding sites, and you change this binding site conformation. Then what happened? Virus or the whatever, they cannot attack, right? I don't know whether you understand what I'm saying. That means you get sick. Why? There are some unwanted reactions in your body. If you can prevent those unwanted reactions, what you can protect from that disease, you can prevent it happening. That's what the medicines are doing. Medicines are not allowing to take place these unwanted reactions to make some unwanted chemicals inside your body. So it can be cancerous even. Then you can put anti-cancerous drug. There are different methods of using these inhibitors or preventing. So but I don't have time to explain that part in detail. That is called clinical biochemistry and computational. There's something called, this is very important, computer aided drug discovery process. We call it CAAD, computer aided drug discovery process, CAD. There's something called CAD tools. If you want to search in the internet, computer aided drug discovery process, CAD tools. So that is called, it comes from computational chemistry. Computational chemistry. Have you ever thought about computational chemistry? We use computer softwares, and you take the, you had most of you in biology, ne? You get the maybe the three-dimensional 3D structure of protein, and then you have different enzymes. Different enzymes, you check which enzyme is going to bind with this active site. So active site you can change, or you can change the enzyme, or you can send a block, I mean some other receptor. Okay, so like that you can do it. So this COVID-19 also same thing, no? If we can change, then it will, if we can block the reaction, or if we can prevent the reactions happening, or if we can prevent the virus binding to this various parts, and then they cannot survive in the body, they cannot reproduce. So to reproduce they need some enzyme, they get the reactions with the help of, we become the host. So that is, now if you are going to do this clinical, like in laboratory, you need so much chemicals, ne? You can reduce the time taken for the drug discovery process by using computational chemistry. Computer algorithms they use, and first they use the computational chemistry, then they find the most suitable targets and the protein, and then they will go for the clinically in the, I mean the laboratory work. If you directly start with the laboratory work, what you mix that chemical, this chemical, and check what happened. That chemical, so much, it's environmental pollution, cost is very high, it takes long time. So this is like few seconds. So this computational chemistry, you guys, like architecture, you design the maybe building or whatever. So this computational, remember, only IT is useless, only computer science no use. Computer science plus accounting, or IT plus account, and then you can have a payroll, or like maybe banking, or maybe software, like which, so a computer science or IT plus chemistry, computational chemistry, right? Or physics, like that, various software. So it's with you should be very good in one subject with computer science, only computer science if you are doing. That's why you can't do A level only computer science. So if you are doing, if you want, you can do A level, you can drop chemistry and select what, physics, IT, and combine maths, or maths, higher maths and IT, like that. So this is very important, now one of the very demanding field in the future. If you are good in chemistry, and if you are good in computer science, then you can become a computational chemist. Computational chemistry, if you enter university, you can do computational chemistry 4 years special degree, right? 4 years special degree, and you can become I mean kind of a chemist, those who are working on drug discovery process. Remember, medicines or the drugs in the world prescribed by the doctors, but synthesized or found, I mean discovered by chemist. Who discover the drug? Chemist. Who prescribe the drug or the medicine? Doctors. So therefore, the most important thing, not to prescribe drugs, to discover drugs. That is the most difficult thing, no? So the most of the students, those who are doing bioscience, they don't see that side. They see, medicine, parents think my son is doing A-level bioscience, my daughter is doing A-level bioscience, so he has to, she has to be a doctor, MBBS, right? They don't know beyond that. No, I'm not telling all the parents, some of the parents they think, but remember there's so many things beyond that, right? Genetic engineering also there, ne? So sometimes you think engineering only related with physics, maths and all, right? Mechanics. No, there's genetic engineering, right? Bioinformatics, biotechnology, right? There are so many areas you can. Okay, anyway, now the middle one you can easily write now, anhydrous, AlCl3 and CH3 Cl, right? Okay, shall I erase this? So done. Is that clear now? Vinhar and Ishara are not replying much, so I'm wondering, especially Ishara, are you okay? Are you comfortable with this, or you need any clarification? Please tell me, because otherwise no point of only few students are joining for this online paper class. Get the maximum benefit every time, and I'll give from my side I'm giving the maximum, so that you also can open your mouth, unmute, and you can reply. You can annotate on my screen always, because they get the maximum. If you are going for a mass class, you will not be able to open your mouth, you can't unmute, so you can just you become the audience 100%, right? Now here you should interact, then only I know up to which extent you have understood, then I can decide my speed, right? Then number 7, okay, seventh one, number 7. Okay. After this, when you are okay with this part, we can move to the past questions of this section, right? That's right, I'm trying to do. I will do like this. Scene. This one. How to do this? Who can, any volunteer? So if you only can annotate on my screen. I don't need to write the reagents, so you can write just the intermediate products. What should be the first step? There are alternative methods also here. How to synthesize that? I'll do maximum 10 here, then if you need more practice, I will give some for homework. What should be added first? Yes, you can add. What is added first? Chlorobenzene. If you want, you can add chlorobenzene. You can add chlorine first. Chlorine also, it's a deactivator, but orthopara director. Chlorine also orthopara director. Or else you can add, having that in mind, how to get COOH group? You can get COOH group from CH3 group. You can get COOH group from CH3 group. So then having that in your mind, you add CH3 to get chlorine, right? To get chlorine. Then you can add chlorine here. You can add here chlorine. After that you oxidize this CH3 to COOH. Or else there's one more alternative method. If you want, you can try with chlorine first. I'll show that path also. You can get chlorine first, because chlorine also orthopara director. Chlorine also orthopara director. Chlorine. Then this chlorine you react with CH3Cl, AlCl3 to get this. You add chlorine and then you get CH3. There are some organic conversions, they will give alternative answers. Some ALL papers, marking scheme, they have given first alternative, second alternative, like that. Okay. If some papers they give with the reagents, right, to do the conversion. Now after that you can oxidize this to directly into the final product this way. Is that clear? You can copy down both these routes. Reagents you can remember, right? This is AlCl3, anhydrous AlCl3, and chlorine Cl2. Then you can put here AlCl3 and CH3Cl, anhydrous, anhydrous AlCl3, CH3Cl. After that you can put acidified KMnO4, acidified KMnO4. This one you can put AlCl3 and CH3Cl. This one you can put AlCl3 and anhydrous, anhydrous AlCl3 and chlorine. This one you can put acidified KMnO4. Okay, but anyway, in both the methods, so acidified KMnO4 should be added last. Acidified KMnO4 is the oxidizing agent which can oxidize CH3 to COOH. if at least one hydrogen is directly attached to the, I mean, CH, if you want to write this CH3 group, okay, CH2OH group, right, CH2OH group, in addition that CH2, CH3, any of this you can oxidize by using acidified KMnO4 to COOH. Please remember that any alkyl group directly attached to the benzene ring, any alkyl group directly attached to the benzene ring can be oxidized by acidified KMnO4. Acidified KMnO4. Is that clear? Any questions? Any questions? Shall I erase this? Anyone still copying down? Please raise the hand. Anyone still copying down? Please raise the hand. Done? Okay. Let's move on to the next one now. What is the previous one I gave? Number 7, no, number 8. I'll do only 2 more after 10th one, then you can manage the rest. You can. So number 8, I'll do this one. Let me do this compound. Have I given this before? No, right? NO2 and COOH? No. NO2 and COOH? No. Right. Okay. Can you try this? Yes. If you want, you can annotate on my screen, or else you can quickly reply to the chat. One first this, second this, third this, like that. You can put Roman number 1, these other reagents, Roman number 2, these other reagents. That way also you can put the answer to the chat, because benzene ring you can't draw it. You can number third step, you can draw, like if you can do this in 3 steps, you put the first, second, third, you can put the answer to the chat like this. 1 this, second this, third this, the reagents at least, or else you can draw on my screen. VDCWH and NO2 like this. Okay. Have I done this before? COOH and NO2, but this O2 and para we didn't do, right? This is what I did. Pramodi, I gave this way. NO2 and COOH I gave this way.
Yes, sir.
Okay, so but that is meta and meta position NO2. I have given the para. Okay, there's a difference between that and this. Okay. COOH and NO2 I gave, but not in these two position. That is in the meta position, right? Now, Tamasha gave first you had to put CH3, okay, and then you put COOH, and then you put oh, very good, right? Correct, very good. One first step you put COOH. What about the Ishara? And Ishara is not replying at all. Ishara, are you there? Or do you get it? Okay, okay, then no problem. If you have got it, no problem. Otherwise, I don't know whether you find it, whether you have got confused with this, right? Okay, you can try this alone, because if you can get the answer before me, your thinking ability is improving. If I am giving the answer before you do this, before you think this, at least you before you make an attempt to do this, then you are thinking only I will be improving. I am improving, not the students. That's why I'm giving the maximum chance to get the answer from you at least halfway. Maybe you might not get the perfect answer, but that is important. Your thinking abilities, your analytical thinking, logical thinking, reasoning. So that is improving. That's what you need for the exam. Right. First, what should be added? Some of you have given the perfect answer. Very good. Very good. First, you put Vinhara gave concatenation HNO3 concatenation so first, and then CH3. That is the problem, Vinhara. If you put NO2 first, Vinhara, can you get to the meta position, para position CH3? That is the problem. Vinhara, do you understand what I'm saying now? You have put first NO2, concatenation NO3 concatenation. So if you put NO2 first, and then what happens? CH3 go to here. Then you will get that previous. That is what Pramudi asked. So we have done that before. Like that is what we did before. That then you will get something else. Then you get busy like meta position COOH. Do you understand what I'm saying, Vinhara? That is, we have done this before. This one we have done before, but here we can't. We should get in the both are in the 1 and 4, not 1 and 3. Okay. So therefore, if you put NO2 first, then you are in trouble. If you put nitro group first, you are in trouble, because that is a meta director. That is a meta director. That is okay. Good that you replied, because when you are replying, don't hesitate to put the whatever the answer that you guess or think, because if you put the wrong answer, then I can explain how that happened. Then also you will learn. Your knowledge is improving. If you without replying, if I am directly giving the product the answer, then you will not improve. Because most of the classes, what is happening? Teacher is making the question, tuition class, teacher is explaining that. The question also teacher explain. Teacher is giving the answer. Again what? Teacher is making the question. So is the tuition classes also, in most of the time in school also, teacher is making the question. Teacher is explaining the question. Teacher is giving the answer. Who is improving? They are improving. They perform better next year batch than not the students. Okay. So that's why I will try my best to get at least like halfway through the answer from you. Then only you are improving, because you have to think now before you write this. Now, what is the first one? You have to get, having that in your mind, you have to get CH3 here. That is a orthopara director. Remember, you need two things here. Orthopara directors, meta directors, you should know. Next one, the organic reactions of benzene related organic reactions, you should know. Otherwise, you are in trouble. You have both the notes. Then, after that, you can easily attach this into para position, because methyl group orthopara director. Para means fourth carbon. I don't know how many of you can remember orthopara directors now. You were there, right? 1, 2, 3, 4. The fourth carbon is para, right? Para position. Then you get the para position, because this is methyl group orthopara director. Either ortho position or para positions, you can get it. Then you will get, you can directly convert this into what? COOH by putting acidified KMnO4. I think now everyone should be okay with this. If I do 1 or 2, like it's enough. No, you can manage this, right? I think Tamasha is fully okay. She is according to the way she replied the answer, so I think she is okay. But what about the others? I will do 2 more examples, but at least more than 50%. If you're okay, then no problem. Then when you are doing the papers, you will get the rest. But because I can't directly go for the papers without teaching this. Even if you go from, I think theory class, I think you don't need theory with this organic revision. because I am giving the summary and I am explaining that summary again with the theory, and then again I am doing the papers. Because I can't wait until you complete your all theory, then we will not be able to complete the syllabus. We will not be able to revise the entire syllabus. You CH3C, right? Done? Got it? Shall I erase this? Okay. Then let's see this one. I'll put number 9. Number 9, I'll do 2 more. Number 9. This one. Can try this one. Yes. Can you? What is how to do this? Because I gave all the examples I discussed with you with meta and meta position and para positions. Now I gave one with ortho. Ortho is the first carbon, second carbon. No? If ortho is so this give the highest priority if it give this one chlorine. So this is second carbon is ortho. Therefore NO2 is at ortho position. Yes. Pramodi, if you okay, Pramodi gave one answer. Ishara gave Ishara correct. Chlorine first and then KMNO4 on it here. KMNO4 on it because we are not going to convert the CWH. We are not KMNO4 not necessary. Ishara you can put CONCH3 and CONCH2SO4. Tamasha chlorine first and then CONCH2 CONCH2SO4. Okay, very good. Tamasha correct. Vinhara also correct perfectly. Vinhara and Tamasha correct. Pramodi and Ishara, your order is correct. Chlorine first and then it should be CONCH3 and CONCH2SO4, right? No need KMNO4. Pramodi the problem order, right? Pramodi, if you get NO2 first, I'll explain the Pramodi's answer first. Pramodi has put NO2 first. If you put NO2 first, can you get NO2 is what director? Meta director. So if you put AlCl3 and chlorine, Pramodi, can you will you be able to get chlorine into the second carbon? No, chlorine will definitely go to what? Third carbon because NO2 is a meta director. NO2 is a meta director, then you will end up with some other product. Then you will get chlorine at the meta position. Do you understand what I am saying? Pramodi, is that clear? If you put CONCH3, CONCH2SO4 first and then chlorine AlCl3, problem will be this. Understood? Pramodi?
Yes, sir.
Okay. Then, so therefore you have to always be careful if you same reagents, but if you don't put them in the correct order, then it will be a problem. You get something else. So I'll write the correct answer now. You can first write get chlorine by putting anhydrous AlCl3 and Cl2. Anhydrous AlCl3 and Cl2. and then you can get directly NO2 to the ortho position. Now remember this also there. If when you put conc HNO3, conc H2SO4, remember you will get both this actually. But we write our desired product. You get chloro orthonitrochlorobenzene as well as para-nitrochlorobenzene, both you are getting. Orthonitrochlorobenzene and para-nitro, both you are getting. But we are interested with this product, therefore we will go for that. And we don't write the other one. You can get both this. Both this you are getting. Understood? Chloro is, please write with a, put a small, put a star right near this. Chlorine is weak deactivator. Chlorine is a weak deactivator, but it is what director? Ortho-para director. But ortho-para director. Ortho-para director. Why? Because chlorine is, what is a deactivator means it withdraw electron from the benzene ring. Chlorine will withdraw electron from the benzene ring. That means chlorine electron density decrease in the benzene ring. In the benzene ring, electron density decrease because chlorine withdraw electron from the benzene. That is the meaning of deactivating group. Then deactivated benzene is less reactive than the normal benzene. Deactivated benzene is less reactive than the real benzene. So, but the problem is this. But when there are lone pairs, then they are contributed for this. Even though chlorine is electronegative, it will repel electrons, so it will donate electrons to the benzene ring because of the availability of lone pairs. The same scenario, can you remember the other orthopara? I don't know how many of you can remember that orthopara director. Sometimes you can argue, sir, how OH become orthopara director, because it's oxygen is the second most electronegative element, but there are lone pairs on oxygen, and then these lone pairs undergo resonance stabilization in the benzene ring 5 electron cloud. So that is called resonance stabilization. I have given, I think, the resonance structures also for this. Right? You can check your writing book. That's how it. When there are lone pairs, same scenario. When NH2 group is attached to the benzene ring, what happened? Sometimes you might argue, sir, nitrogen is more electronegative and this will withdraw electrons. How this become orthopara director or activator? Yes, nitrogen is electronegative, but there's a lone pair on nitrogen. That's why. Okay. But remember NO2, look at here, this NO2, no such lone pair. If you only can expand the NO2 group, if you only can expand the NO2 group, nitrogen has no lone pairs. Nitrogen has no lone pairs in NO2. NO2, nitrogen has no lone pairs. Right. So here 3 bonds, and then the lone pair is from a coordinate covalent bond with oxygen. So no lone pairs. That's why NO2 become what? Deactivating group. Even though nitrogen is electronegative, in the NH2 group it becomes strong activator. NH2 becomes strong activator because there is a lone pair on nitrogen that can undergo resonance stabilization in the benzene ring. But NO2 group, again nitrogen is directly attached to the benzene ring, but there are no lone pairs on it. Is that clear, everyone? So therefore this orthopara director very important. If you have no proper understanding about orthopara directors and activators, deactivators of benzene, then you will find this conversion hard. So that lesson we have done before. Right? And remember, now I am uploading all the class recording also to the YouTube channel. So it takes time for me, and it takes time and data and everything. So for uploading that again is a additional work. But anyway, I will hope you will be benefited them in the later. Remember now, but from August only I started doing that. Before, the recordings are not available actually in the YouTube channel. You can whenever you want, you can watch those recording. If you have forgotten anything, if you want to revise that part, right? So under the title also I have put under each video, right? Whether it's organic, physical or inorganic, and the lesson which part. Then is that clear, everyone? So chlorobenzene orthopara director, that means you get ortho product as well as para product both. Chlorobenzene, right? Even if they give this one as the product, then also the same route. Right? Okay. What is this, Tamasha sir? From this month, I have a physics extra class from 8 on Wednesday. 8 in the morning, right, Tamasha? Then what to do? Um, uh, then we are doing the class 8 until 8:30. Then I had to do 5:30 to 8. Then you will be until what time you have the physics class? Until 11. But the problem is, I think then we have to switch to the Tuesday night. Tuesday night in physics class, no problem. You don't have any problem Tuesday evening, because earlier you had the physics class on Tuesday, right? That's why we switched to the Wednesday morning. So this is extra classes. Extra classes the whole month. Or only next week. Extra classes until when? Until this month, end of this month, or this month only. So what is your suggestion then? What is the I mean, alternative for us? I think the others are not having a problem. Or are you okay with Tuesday night? Any suggestions, Tamashi? Or we can do Tuesday a little early if you are no, that time also you are not free, no, a little early. Wednesday, like Wednesday from what about Wednesday, like around 4 p.m. to 6:30 p.m. Wednesday then? What about the others? Vinhara has a then Tamash instance Tuesday only for this month. Can we do on Tuesday only for this month? Tuesday, the others not having a problem, right? Tuesday night. Then now only for this month, Tamash is requesting Tuesday evening. And Tuesday we'll do only for this month, Tuesday 8 to 10:30. What to do? Are you all okay? In October. Tuesday 8 to 10:30. Ishar Pramadi okay, Ishara okay. What about Vinhara? Tuesday night then only for this month, Tamash is requesting. Tamash, then you don't have a problem now. Earlier you had a problem Tuesday night also. Now are you okay, right? Tamasha? Tuesday until what time you have the previous class? Before 8 o'clock you had a class, right? Okay. That class is there until 8 o'clock. Okay. But you can manage it this month, no? Then next week you are asking Tuesday night. Okay. Then Tuesday night. Right. It's fine. Then we'll do Tuesday night from next week 8 to 10:30 p.m. Okay. Tuesday night 8 to 10:30 p.m. From next week. Right. Okay. Okay. I will not doubt that. Okay, are you comfortable with this? Now, shall I move to the next one, last one? So then next week we can do the past questions from this section also. I'll give few for homework. I'll send a separate paper from this. So because first I wanted to discuss this with you all before before directly posting the paper. I'll do one more example. Quickly this one, 10th one, no? 10th. Have I given this before? Okay, wait. We'll do like this. Give me a second. Yes, this one. This one. Can you try this? The last one after this. So, yes. How to do this? Can you quickly reply this? What should be added first? Yes, can you quickly pause the, or else you will do this for homework. I'll do this for homework. This one for homework. Oh, sorry. Yeah, Tamasha gave CH3 CH2Cl and then number 2 CH3Cl. No. You can't do like that. Tamasha, that is wrong. You can't put ethyl first and then methyl and no. When you put ethyl first, what happened, Tamasha? The methyl also will come to the para. When you put ethyl is auto para direct. This is bit more complex. Anhydrous AlCl3 acidified KMnO4. No, we are not trying to get chlorine here. Pinhara. Tamasha CH3 acidified KMnO4. Ah, that was correct. Okay, perfect. Second attempt, your second answer is correct, Tamasha. What about the others? Yeah, this is how you should do it. First you can get CH3. You can put the first group to anywhere you want. Okay, to any carbon you can put the first group. Respect to that, it depends on the ortho para. Now, for this is a para. This is what director. This is ortho para director. Then you convert this into COOH group. For the COOH group, what is the meta position? This is 1, this is 2. Third carbon is meta, no? Third carbon is, then you can get the meta position, the next group. That is CH2, CH3. Is that clear? Okay. What is the first reagent? Anhydrous AlCl3 and CH3Cl. Then next one you get acidified KMnO4. Okay. After that you can add anhydrous AlCl3 and CH3 CH2Cl. Are you all okay? But there will be an interference, or later you will understand that, but anyway at this stage you will accept that, but there can be a side reaction. Okay, you will be very, very careful. Now if this group is going to react with this, that will be a problem. That can happen here. Therefore later I'll explain how that happens, but here, like for the organic conversions, we can write this, right? But sometimes what happen, if the next reagent is going to react with the previous product, this group, functional group, then that will be a problem, right? So that you have to be very careful. So there's an alternative method for that, but I will, because that reaction we haven't done it, that's why I give this. Right, okay, then so benzene we have done everything now. Then I have to start with the other organic functional group, new functional group next week. But before that, I'll discuss some past paper questions from this, right? Some past paper questions from this. I think already I have shared this paper with you all. It's 9:15. This paper, no, this organic short. Please refer this organic short notes also. This one I have posted to WhatsApp group. Right, organic short notes. There's one more organic short note. I'll post that also within next 2 weeks. This is the identification of organic compounds chemical test to distinguish. Because last few years A-level papers they have given this. That's why. Okay, then there's one more thing I forgot. 2000 organic equations, organic reaction type. No, this paper I think. This paper. Can you have to do the remaining questions of this paper, right? Especially, can you see here? Now this benzaldehyde is what director? Who can tell me what is benzaldehyde? Now look at here number 2. Can you all see the screen? This is, you need the orthopara director. These are LL pass, all these are LL pass papers, right? This one, all these boxes, this is how you get the questions in the LL paper structured essay. So this number 2, how to decide the reaction type and the major product here. Forget about the reaction type, what is the major product here? You should know whether this is orthopara director or meta director, CHO group. Depending on that, you have to decide the place. So this is number 1, then this is number 2, this is number 3. The third position, who will this will come to the third carbon because this is a meta director. You understand what I'm saying now? Then the major product will be what? Benzaldehyde, C double bond O. So if this is no lone pairs on the carbon atom, so this is aldehyde group, ketone group, meta director. Aldehyde group, ketone group, meta director. So you can put the first group anywhere you want, no problem. Try to do this at home, the possible ones. So you have to put the meta one here, right? So it's okay. I'll put the exact place they have put here. CHO group. CHO is aldehyde group. If you expand that and draw it, it will be like this. Like this, ne? Then CO, CH3, COCl, anhydrous AlCl, that will come to what here? CO, CH3 like this. Is that clear? So you need that knowledge to do this. It's like a soup. They will give, they have given one from this type, benzene related one. That's what we are talking about today. This one we have done before. This one we have done before. Okay. And the others you can do. Even this is also here. Can you see here? Look at this one. Look at this one. This also you can do now. This also I forgot to put the ALL paper here, which here, but these are like 2000 to 2010 ALL papers. 2000 2010. What is the major product here? Reaction type and the major product. These are LL paper questions. Major product you can easily decide now, no? What is this? COOH is here. And then NO2 come to what? Meta position. What is the meta position here? 1, 2, 3. Third position is meta. And then you get here third position meta. What group? NO2 group. Because COOH is what director? Meta director, deactivating group. Is that clear? So this is what you are getting from what you learned today with me. The LL paper. Sometimes instead of, now this is much easier. This is what electrophilic, all these electrophilic substitution reaction type electrophilic substitution. Sometimes they can give the same thing in the A-level essay type paper. If you get the same thing in the essay type paper, they will give the product like this, same reaction. The same reaction they can give like this way. They will start with the benzene and they will ask you to do the conversion. To do the conversion, you get here the major product like this, NO2 come here and COOH goes here, right? Then what happened in the ALL paper, they will directly give like this, COOH here, and to do from the beginning without giving anything. It can be more complex. Then you can do that in 2 steps. You understand what I'm saying now? So this is very, very important, because if you get this in the structure, this is compulsory. No choice, right? So then try to complete this also. Even this one you can do. This also you can do. This one you can do. This one you can do. Do you understand? So I want you to complete this next week, the third one. Okay. Please mark all what you learned from today. This also LL paper passbook question. This one we have done, right? Now gradually you want, you will be, now this one except the fourth one you can do everything else. Everything else. Carboxylic acid we didn't do. Understood? Okay. Then we'll stop for today. And we'll continue the rest next week. Please do this for homework. This I put this this one we have already done. This one for homework. Right. Okay then. Okay, it's 8:40 now. We'll stop for today. And next week we'll have Tuesday night 8 to 10:30 p.m. Okay. Right, then have a good day and God bless you and stay safe.
Thank you, sir.
Thank you.
Thank you, sir.